Happy wedding. In today's class, we are going to see combination of non-metals. See, last class, last 2 days, we studied formation of ionic compounds. That is what we used to say. Combination of metals and non-metals. So when metals and non-metals will combine, that is what will give us ionic compounds, and ionic bond will form. So we studied, I think, 5 examples for ionic bond formation and what is happening inside the ionic bond formation and what is the properties of ionic compounds. Am I right, everybody? All of you? So now let us come to the today's class. We are going to make the next type of compounds, which we used to call as covalent compounds. So the covalent compounds only formed by combination of non-metal with another non-metal. So here what will happen, guys? Only sharing of electrons will take place. Keep it in mind, whenever the non-metal is combining with another non-metal, combination of non-metals. So this concept very important for next chapter. Next chapter means carbonate compounds. So if you are very good in this concept, next chapter will be very, very easy because many questions will come. Entire concept will run with the non-metals only because entire carbonate compounds is fully non-metals. So please be very attentive. So combination of non-metals means in the sense of what bond will form, everybody. Combinations of non-metals means in the sense of it will form covalent bond formation. Okay, so let us start with that. So all of you remember the chemical reaction will take place by 3 ways. So first one, both together I will say, one has to donate the electrons and another one has to receive or accept the electron. So this is what we used to call as what compound, everybody? Ionic compound. Understanding? So now the third one is only by sharing of electrons. So this is what we used to call as, what we used to say, all of you? Covalent one. Understanding? Donating and receiving. Donor, we used to say metal. Receiver, we used to say non-metal. So when metal donates the electron, non-metal receives the electrons. That is a bond. What is a bond will form, everybody? The bond will form is ionic bond. Now, one non-metal will share the electron with another non-metal. Then that is the bond will form. What is the bond we used to call, everyone? Yes, please. Covalent bond. Understand? So, non-metals will combine together only by donating and sharing, or donating and receiving, or only sharing, guys. Everybody. So the non-metals combine together with what? All of you? Through, yeah. So through sharing of electrons. Sharing of electrons. What is the purpose, guys? To become what? To become stable. So by sharing, both combining atoms become stable, not one. Understanding? So by sharing, both the combining atoms become stable. So that is only we used to call as, what we used to say, covalent bond formation. So if you observe here, the chemical bond formed due to the sharing of electrons. So due to the sharing of electrons, what bond will form, everybody? Yes, please. Covalent bond. Yes, the bond which is formed between the atoms, we used to call as covalent bond. Okay. So now formation of covalent bond takes place when both the bonded atoms require electrons to achieve the stable inert gas configuration. So that is the most important point about the covalent bond. See, the both atoms need electrons. Do you understand it? Ionic bond means what will happen, guys? Ionic bond, what will happen? One need electrons and another one need to remove the electrons. One is interested to lose the electron, another one is interested to gain the electron. But in covalent bond, both atoms need to require electron to achieve the stable inert gas configuration. So that is the difference between ionic bond and as well as covalent bond. So please write that point. Formation of covalent bond takes place. Formation of covalent bond takes place. Formation of covalent bond takes place when both the bonded atoms require electron. For what purpose, guys? The required electron to achieve the stable inert gas configuration. Omar, are you there? To achieve the stable inert gas configuration. Are you clear, everyone? All of you? Next, types of covalent bonds. Types of covalent bond. Remember, first of all, of course, the covalent bond is formed by metals or non-metals, guys? Everybody? Covalent bond is formed by what? Non-metals. So now, let us again revise the concept which we studied. Can you tell me valence electrons of non-metals? Valence electrons of non-metals. All of you? Yeah, basically four also will consider, but of course, four neither we can say it will never comes to donating or sharing. That's why valence electrons will say here. So 5, 6, and 7. What is the valency, everybody? Valency. 5 means 3, 6 means 2, 7 means 1. So 3 to 1 is the valence. So that is what? Sharing of electrons is maybe 1. Sharing of electrons is maybe 2. Sharing of electrons is maybe how many? Maybe 3. Understanding, Amma? So, or you can notice it. If I take carbon, like for example, carbon, what is atomic number? Anybody? 6. Electronic configuration is 2, 4. So to achieve the inert gas configuration, it wants to share all its 4 electrons. Am I right or wrong, everybody? Yes, please. All of you. That is what. So it has 4 electrons only in its valence shell. So it needs to become stable. Then it wants to share all the 4 electrons with another four different atoms or maybe some other thing to attain the stability. Of course, we'll discuss that. So let us see the types of covalent bonds. All of you observe. Covalent bond is formed by, as we all know that, how it will form? By sharing of electrons. So depending upon the number of electrons shared, covalent bonds is classified into 3 different types. So first thing is single covalent bond. Next chapter full of this only. Single covalent bond. So please write it. So how many electrons will share? Everybody, single covalent bond. The type of covalent bond is formed by the sharing of how many electrons? All of you. Sharing of single electron. Understand? Single electron from each bonded atom. Each bonded atom. So that is what we used to. So totally how many electrons will share? Suppose this one atom will share 1 electron. And a second atom also will share 1 electron. So totally how many electrons is sharing? Check it, everybody. 1 and 1. What is that called as? Yes, please respond. A single pair of electrons takes place between 2 bonded atoms. How many pairs of electrons, everybody? Yes, please.
Single pair of
Single pair of electron takes place between the two bonded atoms. So that is what we used to call as single covalent bond. So for example, I'll take hydrogen. So hydrogen, what is the valence? Atomic number, tell me hydrogen atomic number. Hydrogen atomic number, fast everybody. 1. So means it has how many valence electrons? It has how many valence electrons? 1. Understanding? So another hydrogen also, it wants to become stable nearest inert gas electronic configuration. Can you tell me what is the nearest inert gas? Nearest inert gas.
Helium.
Yes. Helium. So what is the helium atomic number? Helium atomic number 2. So to become stable in nature, it needs one more electron. So it will combine with one more hydrogen atom, and this hydrogen will share electron with this. This hydrogen will share electron with this. So this hydrogen atom will feels that it has how many electrons? 2 electrons. And this hydrogen atom also will feels that this is having how many electrons? 2 electrons. So totally how many electrons is shared between them? Everybody? Single pair of electron is shared between them. I'll explain. So remember, one line if I draw means one pair of electrons is shared. If I draw two lines, two pairs of electrons is shared. If I draw three lines, how many lines? Each line indicating one pair. So totally how many pairs? Everybody?
Three pairs.
So single pair of electrons is shared. That is what we used to call as single covalent bond. Now, if I take chlorine, see that hydrogen gas will write H2. Chlorine gas will write Cl2. We'll write HCl. Understanding? We'll write ammonia. We'll write H2O. We'll write CH4. All of you check it. Everywhere I'll draw compound. Cl with Cl. HCl. H with Cl. NH3. NH3. H. Ammonia. Hydrogen. We all knows that. Hydrogen what? Oxygen with single bond with a single bond. Okay, you can write here. So single bond. How many pair of electron? Have you checked it, everybody? Everywhere? How many electrons? Single pair of electrons. Understand? Next, CH4. Just now I said carbon will share how many electrons? 4. Carbon will share how many electrons? 4 electrons. But 4 electrons not with the same atom. See that how many different atoms? 4 different atoms. So this is what? So have you noticed it, everybody? Single covalent bond means how many electrons will share? One pair of electrons. That is what we used to call as single covalent bond. Do you understand, everybody? Please respond, all of you. So if one pair of electrons is shared, that is what we used to call as single pair of single covalent bond. Next, double covalent bond. What do you mean by double covalent bond? Anybody? How many pair of electrons? Yes, please. The covalent bond is formed due to sharing of
2 pair of electrons.
yes. Due to sharing of two electrons. 2 electrons from each bonded atom. 2 electrons from each atom is called double covalent bond. Girls, are you writing, Amma? Mr. Nimesh, understand? So, all of you remember, whenever they will share 2 pairs of electrons, so it will form double bond or single bond. Everybody, it will form double bond. Understanding? So, remember how many pairs of electrons will take? Everyone? 2 pairs of electrons takes place. Okay. So now, for example, O2. Can you tell me each one? What is the atomic number of oxygen? Atomic number of oxygen? 8. So 2
Eight.
comma 6. So to become stable, it needs how many electrons? Everybody needs
2 electrons.
respond 2 electrons. So next oxygen atom also, it needs 2 electrons, to become stable. So what will happen? One oxygen atom will share 2 electrons. Another oxygen atom also will share 2 electrons. Of course, we'll draw the structure, don't worry. So finally, what will happen? They will form O2 molecule. See, O is the atom. O is the atom, O2 is the molecule. So that what is the bond present here? To become a stable in nature, it will form how many pair of electrons? Everybody? 2 pairs of electrons. Understand? So for example, carbon dioxide, CO2. Check it everybody. Carbon totally how many electrons it can share? Everyone? Carbon how many electrons it can share?
4 electrons.
4 electrons. So one carbon with the 2 electrons, 2 pairs of electrons, another carbon with the 2 electrons, so that they will form C double bond O double bond O. Next, I will say you the compound ethane. So C2H4. What is that? What is the name of this? Not CH4. What is that? Everybody? C2 H4. Okay. Next chapter we will get it. We'll study. So full of next chapter these things only. This is what? Ethylene. What is the name of this one? Everybody? Ethylene. Okay. So if you notice it, C2H4. So how many carbon atoms? How many carbon atoms? All of you. Respond.
So
4 carbon atoms. Now remember, totally each carbon share how many electrons? Each carbon will share how many electrons, guys? 4 electrons. Yes or no? Please respond. So, but with hydrogen, they can share only 1 electron. With hydrogen, they can only share 1 electron. So, in between them, they can share 2 pairs of electron. So, that is the structure of ethylene, C2H4. Again, remember, with each hydrogen, they can share 1 pair of electron. And among themselves, they will share how many pairs of electron? Everybody. They will share 2 pairs of electron. So, like this bond, even single double bond is forming, we used to say double covalent bond. So, when 2 electrons are shared, what is the bond formation between them? Everybody? Yes, please. It is double bond. Understanding? So this is what double covalent bond we used to say. I hope everybody understand. Actually clear? Next, third type of one, triple covalent bond. So please make it. What is that? Triple covalent bond. So now triple means you all by this time understand. How many electrons has to be shared? Everybody? Due to sharing of
3 electrons.
3 electrons from each atom, not 3 electrons. 3 atoms from each atom means totally how many pairs?
3 pairs of electrons.
3 pairs of electrons. Each bonded atom 3 electrons will share, so that it is totally how many pairs of electrons? Everybody? Yes, please. Triple.
3 pairs.
So triple covalent bond. Somebody call to Mr. Arun and Nimish both. Omar, I will call you 2 times. Please respond me. Are you there? Mr. Pugal? So formed due to the what, guys? Due to sharing of how many electrons, Pugal? Sharing of 3 electrons. 3 electrons from each atom. Is called triple covalent bond. Everybody clear? So totally how many pairs of electrons takes place? All of you?
3 pairs of
Yeah. 3 pairs of electrons takes place between the two bonded atoms. All of you understand? So for example, N2. How many of you know N2? N2 means what? Nitrogen. Nitrogen molecule. Am I right or wrong? Everybody. So nitrogen atomic number, tell me. Nitrogen atom atomic number. Fastly. Everybody. Nitrogen, ra. 7.
7.
Yes. So nitrogen is 7. So what is the electronic configuration? All of you. 2, 2, 5. So to become stable in nature, how many electrons it needs? Need 3 electrons. So they will combine. Each nitrogen atom will share 3 electrons so that they'll become stable in nature. Do you all understand, everybody? Yes, please. All of you? Respond. That is. Now, for example, there is a compound in chemistry. Next chapter you will get it. Acetylene, we used to call it as C2H2. C2? Yes, please. C2.
C2H.
So also we can call it as ethine. Start learning from this chapter itself so that next chapter it will be very easy. Otherwise, next chapter will torture us like anything. Hundreds of compounds will come. Very difficult to remember the names. Everything similar, but it's not same. So ethine, what is the formula of ethine? Everybody? C2H2. So totally 2 carbon atoms. One hydrogen they can share only how many electrons? With hydrogen they can share only how many electrons? 1 electron.
1 electron.
But remaining 3 electrons has been shared among themselves. So that is how the triple bond will form. Ethine, or we can say acetylene. Okay, so please write it. Any doubt? Please ask. Clear, everybody? Mr. Nimi's class by 5 o'clock, not by 5:30. Whatever I say, you follow, you do whatever you like only. I know very well. What I should do, enjoy. Please make it, guys. Till here, any doubt, please let me know. Hiranmay, understand? Jivitesh, Harvignesh. Yes, please. Anything doubt, ask me. Call to that Arun, idiot fellow. Call him, somebody. Hare Krishna, see what is the disturbance. Harani, understand Harani? Omar is already slept, I know very well. Johan, there in meeting?
Yes, sir.
Yeah. Have you written notes, Mr. Kaushik? Kaushik? Okay. So please make it formation of some covalent bonds. Keep reading. Formation of, when I call, if you're not able to speak, text me. I'll see correct chart you can make. Hiranmay, are you there? Formation of some covalent compound, covalent bonds. So first, formation of hydrogen molecule. Formation of hydrogen molecule. So we know that hydrogen atom has only how many electrons, guys? Everybody. Hydrogen atom has only how many electrons? Fastly, everybody. Hydrogen atom has only how many electrons? Hydrogen atom has how many electrons? Only
1.
1 electron.
1 electron. Because its atomic number is 1. Am I right or wrong?
Yes, sir.
And 1 electron is present in which cell? 1 electron is present. That 1 electron itself is present in which cell?
Yes.
Valence cell. Because valence cell itself is a what cell? K cell. Do you understand now? So that is what. So what will happen? It will combine with another hydrogen to acquire the stability. So if you observe very carefully, one hydrogen atom is having one electron. That itself is the valence electron. Another hydrogen is atom also is having one electron. That itself is the valence shell. So both they will combine and they will share each. All of you check it. They will share each. So this hydrogen and this hydrogen, they will put their electron in between them. That is what shared. So now only first hydrogen you check it. It is feeling that it has how many electrons in valence shell? First hydrogen atom.
2 electrons.
It has 2 electrons. So it will satisfy. Now second atom also is feeling how many electrons it has. Check it. It has 2 electrons. That is what. Totally they will share how many electrons? Everybody. One pair of electron. Each atom is sharing one pair of electron. So this is indicating single covalent bond. So that's please make it. Single covalent bond. Do you all understand, Amma? All of you? Yes, please. Ma, remaining. Okay, you will make it. So, all of you remember that. Any doubt, you can ask me. So, to acquire the nearest stability, to acquire the what? Everybody. What is the reason? To acquire what? Stability.
Stability.
Hydrogen atoms are not stable in nature. But what is stable in nature? Hydrogen gas molecule is stable in nature. I hope everybody understood. Hydrogen atoms are not stable in nature. Hydrogen molecule is stable in nature. Is it okay, everyone? Clear? Yes?
Yes, sir.
Yeah. Make it. Is errors clear?
Yes, sir.
Yeah. Make it quick, everybody. Next compound. Formation of O2 molecule. So oxygen, how many electrons is there? How many electrons needed to become stable in nature? Everybody? Yes,
2
please.
electrons.
Yeah. So write it. I will draw. See, remaining valence electrons has to be represented. If not, it is wrong. Keep it in mind. So formation of oxygen molecule. I will draw. First you observe. So we all knows that what is the electronic configuration of oxygen? Everybody? Electronic configuration of oxygen 2, 6. So means K and L. Am I right? Totally in valence shell, how many electrons is there? Valence shell, how many electrons is there? All of you. Yes, please.
6 electrons.
So it has shortage of how many electrons? It has shortage of 2 electrons. Understanding? In its valence shell. So what will happen means, all of you check it. One oxygen atom will come. One oxygen atom will come and it will combine with another oxygen atom. So check it, everybody. I'll mention it very clearly. So one oxygen atom will share one pair of electron. Another oxygen atom also will share another pair of electron. So now all of you observe, totally in valence shell, how many electrons is there? How many electrons? 6. So 2 only shared. Remaining 4 we have to represent here. Check it, everybody. Remaining 4 has to be represented above the atom. Here also 2 only share. And remaining how many? Everybody. Remaining how many, Ra? 4 has to be represented above the atom. Now, only first oxygen atom you see. Now, it has how many electrons in valence shell? Count it. Only 1. Forget about the second circle. Only 1. So, how many electrons it has? Count it.
8.
1, 2, 3, 4, 5, 6, 7, 8. Oh, yes, it has 8 electrons. So it will feel that it is stable. Now, second one, 1, 2, 3, 4, 5, 6, 7, 8. It has also how many electrons?
8 electrons.
8 electrons. So that they will feel. Now, remember, we have to draw only valence shell. So, how many electrons? One pair of electron, one line, another pair of electron, another line. So, they will form what bond? Everybody, double bond. Okay, so this is what we used to say, double covalent bond. Is it okay, everyone? So, on remaining electrons, if you forgot to represent this, it is wrong. Understand, Harish? If you forgot to represent hydrogen, why not represented? Why? Hydrogen has only how many electrons? Hydrogen has only one electron.
One electron.
So that is why it is nothing coming. So directly sharing. But oxygen has 6 electrons in valence shell. Only how many will be shared? Only how many will be shared? 2 will be shared. Remaining 4 has to be represented above the atom. So that is what you have to remember. So this is the formation of oxygen. Again, to become what? See, oxygen gas, I told you, we have studied even second chapter or even third chapter. Nascent oxygen. Am I right or wrong? Oxygen atom, highly reactive, no stability. Highly reactive. But oxygen molecule, O2, is a stable atom. Do you understand, guys? Unstable. And this is what? Stable molecule. Stable molecule. That is what. So that is why it will form like that. Next, formation of N2. Anybody? N2 means what? Formation of N2. Everybody. Formation of N2. N2 means what?
Nitrogen molecule.
Hydrogen
Nitrogen molecule. Okay. So if you observe, so we all knows that what is the electronic configuration of nitrogen? Nitrogen atomic number, tell me. Already I taught 7. So 2, 5, K and L. So what is the valence shell? Valence shell, how much?
5.
5. So it needs how many electrons to become stable in nature?
3 electrons.
How many electrons become? Shortage of how many electrons, guys?
3 electrons.
Yes. Shortage of 3 electrons. Others 3 other. Because many people are cheating, correct? That's the reason. So if you are not doing that, that's all your life only. So make it. So 3 electrons has been shared. So what will happen? You check it. One nitrogen atom and combine with the another nitrogen atom. So nitrogen and nitrogen. So totally this nitrogen will donate 3 electrons and this donate share and this nitrogen is also share 3 electrons. So valence shell totally 5 is there. So 3 gone means remaining how many? Remaining how many? 2 electrons has to be represented. Here also 2 electrons has to be represented. Now only one nitrogen you see, it has how many electrons? Count it. 8. 2 plus 6, 8. This nitrogen 2 plus 6, 8. So that both are satisfied. Understanding? So both they will acquire the stability. Each pair of electron one line. So that what is the bond here? Triple. Yes, please. Triple.
Bond.
Okay. So this is all just you see that molecules of element till now we have formed molecule of hydrogen, molecule of oxygen, molecule of nitrogen. Now we will see molecules of compounds. Clear, everybody? Are you ready? Molecules of, yes, molecules of what? Compounds. Clear? Now, when I draw nitrogen, see that almost same size. Nitrogen is same, oxygen, nitrogen, same size. Oxygen, same size. Hydrogen, same size. Now, we are going to form formation of molecules of compounds. Then how it will be forming? You can see. So write it, everybody. Meeting is going to end. Join immediately and make it fast. Formation of HCl. What is that? HCl. What do you mean by HCl? We all people knows. Hydrogen
Hydrogen
chloride molecule.
Hydrogen chloride.
Yeah. Hydrogen chloride molecule. So Let us form first hydrogen. So hydrogen, what is the electronic configuration? Only one electron, K shell. And chlorine, what is the electronic configuration? Everybody, respond 70. 2, 8, 7. How many times are chlorine? That is what? KLM. Here valence shell is M and here valence shell is K itself. So hydrogen to become stable, 1 electron is needed. Chlorine also to become stable, how many electrons is needed? Everyone? Yes, please. 1 electron. So